Hello everyone, this is Greg from ChemCore. In this video, we're going to be going through the worksheet for the Carbonyls, Aldehydes and Ketones video. If you haven't watched the video yet, make sure to check in the description below, and there's a link to the topic video. And if you haven't tried this worksheet yet, there's also a link to that as well. There's also a link to an answer key. Um, in these problems, we're trying to identify the functional group present and specify the hybridization of the highlighted carbon atom. And so in the next couple worksheets, we're going to work on kind of combining concepts from earlier in this unit with functional groups we already know, as well as combine some concepts maybe from Unit 1 or maybe earlier in Unit 2, just to kind of solidify those concepts and how they could be asked in many, many kind of different diverse ways or unique types of questions. And so in this one, I want to combine the concepts of hybridization with functional groups to make sure that you guys don't just, forget all those topics from Unit 1. And so the first question, we have a double bonded oxygen, so we know it's a carbonyl. The thing is that this double bonded oxygen is close to the end of the carbon chain. And so that we can say that this is an aldehyde, right? End of the carbon chain, this is an aldehyde. And this highlighted carbon clearly has a double bond, and and the rest are single bonds, meaning that this is sp2 hybridized. The next question, we have another carbonyl, but this time it's kind of like surrounded by carbons, right? I like to say that it's in the middle of the carbon chain, and my phrase, the key goes in the middle of the lock, so the ketone goes in the middle of the chain, and therefore this is a ketone. And so this is sp2 hybridized. The next two problems, I see a chlorine, and that's instantly telling me that this is a halide, should be connected to an sp3 hybridized carbon, which it is. And so we know that this is an alkyl halide. And this carbon only contains single bonds, and so we have an sp3 hybridized carbon. The next problem, we have this alcohol, right? This is a hydroxide, and so I know it's an alcohol. So I can say that this is an alcohol. You might also say that it's cyclic, it's not a technically different functional group, doesn't really matter. And so this carbon only contains single bonds, and so we know this is sp3 hybridized. And it actually has to be sp3 hybridized because otherwise it wouldn't be an alcohol. The next problem, I see this oxygen in the middle of two carbon chains, and so I know this is an ether. And this carbon over here only has single bonds, and so I know that this is sp3 hybridized. The next problem, I see a double bond and then nothing else going on in the molecule, so I know this is an alkene. And the carbon at the end has a double bond and the rest are single bonds, and so I know this is sp2 hybridized. The next problem, again, I see a hydroxyl group, and so I know this is probably an alcohol. The carbon it's connected to is sp3 hybridized, and that's actually the highlighted carbon. And so again, I know this is an alcohol. And this carbon is sp3 hybridized. The next problem, I see this alkyl halide, right? This is a halogen, and so I know this is an alkyl halide. And for that, it is a requirement that the carbon is connected to is sp3 hybridized, which is actually our highlighted carbon. And so I know that this is sp3 hybridized. The next problem, I see this carbonyl, and it's kind of in the middle of the carbon chain. It's surrounded by carbons, and so I know that this is a ketone. And this carbon that is highlighted has that double bond. It's the carbonyl carbon. And so I know that this is sp2 hybridized. The next problem, again, I see another carbonyl, except this time it's not surrounded by carbons from both sides. Actually, from one side, we have this hydrogen. And so I know this is an aldehyde. And this carbon is sp2 hybridized. In the next problem, I see a triple bond and then nothing else going on in the molecule. And so I know this is an alkyne. And the carbon over here has the triple bond and a single bond from the other side, and so I know that this is sp hybridized. The next problem, well, nothing really going on in the molecule. It's just single bonds. It's a hydrocarbon. And so I know that this is an alkane. And clearly this carbon should be sp3 hybridized. All the carbons in an alkane should be. In the next problem, I see, again, a triple bond, nothing else going on in the molecule. And so I know that this is an alkyne. And this carbon is the triple bonded carbon, and so I know again that this is sp hybridized. The next problem is a little weird, right? We have this hydroxyl, and then we also have this carbonyl. And so we actually have two functional groups. We have an alcohol present, and we also have an aldehyde. And it's an aldehyde because it's at the end of that carbon chain. And so this highlighted carbon has to be sp3 hybridized because that's what makes an alcohol. And then this carbon is double bonded, and so I know that this is sp2 hybridized. In the next problem, I just see a double bond and then nothing else going on in the molecule, and so I know that this is an alkene. And these two carbons are the two carbons, that have the double bond, and so I know that this is also, both of these must be sp2 hybridized. The next problem, I see this oxygen that is in the middle of the carbon chain, and so I know that that is an ether. And this carbon off to the side only has single bonds, and so I know that this is sp3 hybridized. The next problem, I don't see anything going on other than just a hydrocarbon and single bonds, and so I know that this is an alkane. And this carbon only has single bonds, and so I know that this is sp3 hybridized. The next problem, we only have one functional group. Realize that this is a carbonyl surrounded by carbons from both sides. And so even though it's still a ketone, you can kind of call it a cyclic ketone if you'd like. We still technically call it a ketone. This carbon has a double bond, and so we know that this is sp2 hybridized. And this carbon off to the side only has triple bonds, and so it is sp3 hybridized. The last two problems, I see this chlorine, the halogen. I instantly know that it's an alkyl halide. And one of the requirements actually is that it's connected to an sp3 hybridized carbon, which is actually our highlighted carbon. And so this is sp3 hybridized. And then the last problem, I see nothing going on other than, just hydrocarbon and single bonds. And so I know this is an alkane. And these two carbons both only have single bonds, and so they're both sp3 hybridized. And actually, I could point to any carbon in any alkane, and I'll instantly know that it has to be sp3 hybridized. This concludes our discussion about the carbonyls, aldehydes, and ketones worksheet. If you're having trouble kind of understanding these concepts and the concepts from the past, make sure to check out my previous videos in this unit. And maybe try the worksheet again, check the answer key to make sure that everything's correct. And I'll see you guys in the next video.